So this video is about chapter 6 and part 1 is about simulations. So first, when you're talking about a simulation, you're talking about representing some phenomena using the probabilities at hand. So we're going to start off with the example, a couple plans to have children until they have a girl or until they have 4 children, whichever comes first. And we want to know what are the chances that they will have a girl among their children. Now this sounds like a complex probability question. You're going to have some conditions, but let's pretend we don't know enough probability to solve this. So what are some ways to simulate this scenario? Some basic ones would be, we could do a coin, flip a coin, heads a girl, tails a boy, and flip it either 4 times if we end up having 3 boys the first time, or just flip it until you get one heads that represents a girl, and then count how many times you end up with 4 tails out of how many times you flip, and that would be your probability. You could roll a die, even numbers girls, odd number boys, to represent and do the same thing, or you could use a random number generator and do again even numbers girl, odd number boys, and have the same plan. So in mathematics, a simulation, as I said, is just a model based on phenomena that represents the probabilities that are at play in your situation. The more repetitions you do, the closer your results will appear to the theoretical probabilities that exist. One important concept in simulations is the idea of independence, and that is that each trial should be independent of the previous one. So in our example, if I flip a coin, it should be independent of the previous flip, or when I roll a die, it should be independent of the previous roll. One common simulation that's occurring currently is in the presidential election. 538 every day, multiple times a day, run simulations on the probabilities that are taken from polling to figure out what are the chances that Biden will win or Trump will win. This is the latest forecast as of the making of this video, and they pulled out 100 of their simulations, and these were the results of 100 of them. They actually do many more, as you can see, 40,000, but this is just 100 of those simulations. All right, so steps to simulation. 1, you want to state the problem and describe what the randomness is. So we just restate our problem. We have a family, we'll keep having children until they reach 4 children or having a girl. Then you want to state what assumptions you are making. One of them should be what the probabilities are. So in this case, a boy and a girl are equally likely. So, it's 0.5 and 0.5. And also independence. So each child needs to be independent of the other. Then we want to assign whatever we're doing to represent the different outcomes. So if it was heads or tails, you'd say girls equals heads, boys equal tails. We're going to do a random number table, which is used in things like AP statistics, just so that if you're doing a standardized test, everybody can have the same outcomes. Otherwise, it's hard to check because you all have different random numbers. So in that, we're going to say even numbers represent girls, odd numbers represent boys, and then how many times you're going to repeat it. So we're going to do 25 repetitions. Here is a random number table. It's just random numbers. And we're going to take odd numbers. That means we had a boy, we got a girl. So they would have stopped here. So we have, I'll put if they do have a girl over it. And if they don't, then I won't put that there. 1, they had a girl, so they stopped. Odd, 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 odd. So I'll do NG for no girls. Then we have a girl, girl, girl. Odd number, odd number, odd number. Even is 4 children, but they still had a girl. Then girl, girl, odd, 4 odds, it looks like, yes, and so no girl, 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 oops, that's a 6, girl, odd, odd, oh, still a girl, odd, 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 no girl, 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 girl. I know this is exciting stuff right here. Girl, 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 almost done, and girl. And if I did this right, we have 25 outcomes here. So let's see, 1, 2, 3, 4, 5. I think there's 25 there. And out of 3 of those, there were no girls. So we have 22 out of 25 times they have a girl, which is 88% of the time, or the probability is 0.88. Now, assigning digits, you usually want to do the most convenient that is possible. So like on this one, the most convenient is to have one digit represent an occurrence, and if it's odd, it's a boy, if it's even, it's a girl. So we want to be as compact as we can when we're assigning digits. For example, let's say we were choosing a person from a group where 70% are employed. I mean, we could do one digit representing a person. So we could do 0 through 6 are employed, and then 7, 8, and 9 are unemployed. You could do 0, 1, 2 are unemployed, and then 3 through 9 are employed. That doesn't matter. But what is important on this one is that you started at 0, because if we started at 1, we'd have to go to 10, and 10 becomes 2 digits. So if we're using the random number table, we've then bumped up to 2 digits. So starting at 0 is usually your best option. However, you can't always do that, because let's say we had a non-whole 0 as our ones digit. So if it was like 71%, then we couldn't do just one digit to represent people. You could have also, for the previous example, done 0, 0 to 69 and 70 to 99. But that requires you using 2 digits, which would make you use more of the random number table. And then another example, as I was saying, is if you don't have a 0 in that one, then like 73, we do have to use 2 digits. You can have more than just 2 possible outcomes as well. So if we wanted 50% are employed, 20% unemployed, and 30% are not in the labor force, you could still break this up. You could do 0 to 4 are employed, then 5 and 6 are unemployed, and then 7, 8, and 9 are not in the labor force. All right, so that's pretty much it for running a simulation. The next section will go more into probabilities and randomness. Just one last point, if you want to laugh, go to Amazon and read the customer reviews for 1,000,000 random digits with 100,000 normal deviates. They're humorous. I have the 3 of them that come up first on here. So it's a very engrossing book with historical importance. It keeps you guessing until the end. And 1,000,000 random digits, they only use 10 and just keep repeating them in different combinations. Don't be fooled. So there's a bunch more like this if you want to have a little laugh and about numbers. All right, so I will see you in the next video.